Solenopsis invicta, or the red imported fire ant, is an invasive species that has created demand for control and eradication methods. Traditional fire ant control approaches, including insecticides, are expensive, toxic, and harmful to the environment. Bioinsecticides, including essential oils, have become a growing field, but there's a lack of scientific literature to support their effectiveness. Our study aimed to answer the question, does direct application of various essential oils cause a significant difference in Solenopsis invicta mortality rates, and are these differences correlated to chemical composition, in order to explore the effectiveness of essential oils as a sustainable and effective bioinsecticide.
The fire ants were collected on the Georgia Tech campus and raised in plastic buckets. We collected 20 ants and placed them in a ball in the middle of a petri dish and sprayed them with an essential oil from 3 inches away. We collected 4 trials for each essential oil and counted the time of death for all 20 ants. We considered them dead when they were curled up into a ball. Here you can see the average mortality rate for each of the essential oils we tested. In an ANOVA test, we got a p-value much less than 0.05, and therefore there was a significant difference between the mortality rates of the different oils. Using the Tukey-Kramer pairwise comparisons, we created groups of oils that were not significantly different from each other and significantly different from the rest of the oils. Clove and peppermint were the most toxic oils with an average mortality rate of 10.4% per minute.
The chemical composition analysis found a positive correlation between mortality rate and percent of oxygenated monoterpenes. This correlation supports the mechanism of toxicity suggested by previous literature, that oxygenated monoterpenes cause disruption of neurotransmitter receptors. More neurotransmitter receptor blockers likely cause higher essential oil toxicity to fire ants. There was also negative correlation between mortality rate and percent of monoterpene hydrocarbons. This helps us further attribute toxicity to oxygenated monoterpenes. Both the correlation between mortality rate and sesquiterpene hydrocarbons and the correlation between mortality rate and oxygenated sesquiterpenes were found to be insignificant. These findings are essential to the application of essential oils as a bioinsecticide. Isolating chemical compounds in different terpene groups and testing their effective mortality rate would provide a clear picture of their relationship with toxicity and assist in the engineering of an effective and natural insecticide.
Here you can see a basic phylogenetic tree of the essential oils in this study. In an ANOVA, we analyzed the mortality rate of different orders and found there was not a significant difference between the orders. However, the Tukey-Kramer found each order to be significantly different. A more reliable analysis would include more plants within each order. Overall, we found that essential oils are an effective alternative to traditional pesticides. We specifically recommend peppermint oil and clove oil for future commercialization.